Well, good morning, everyone. I hope everyone is having a wonderful Tuesday. Everybody, I just wanted to say, please be safe out there whenever you're out traveling around today. Things are things are difficult these days. All right. So, good morning, Guy and Peter. Today, we're going to be talking about how to properly perform a seal system repair. The first one we're going to go through is kind of before I go and troubleshoot. But when I'm troubleshooting, I want to make sure that I've actually got a problem with the compressor. I don't need to be out there trying to going out and changing the compressor and then it not be the compressor. There's nothing more frustrating than I used to go behind guys that would diagnose a bad compressor. Um, and if it was one of the guys that was new, I would always, go behind and double check and make sure it was actually the compressor. A lot of times it wasn't the compressor. So you have to know that you're actually needing a compressor. But we're going to go through things to check to begin with. Okay. Once we go through that, then we're going to go through a short presentation of how to do it with a torch. Okay. And then we're going to go, we're going to have about a 2-minute break while I get the other program loaded and up. And then we're going to go through with the R600, which is lock ring training. Okay. These are all kind of highlighted. These aren't complete classes. The complete class for just the seal system portion for compressors is about 2 days, and then lock ring is also somewhere between 1 and 3 days. There is a class that was last week. We tried to make it. That class is actually you have to pay for, but I guarantee you get your money's worth out of it. So if you've got a new technician on the board, or you are a new technician, I would encourage you to, the next time that there is a class for lock ring and torch training, definitely go. It's worth your money if you go. And this is not like it's $1,000 for you to go. That they have made it as cheap as possible for you. You would have to get your own. You would have to get your own hotel. You will be furnished lunch and breakfast, which is what Reggie does in the class. That's part of the reasons that they charge, because it causes a whole lot of heartache for Reggie, because he has to actually order the lunch. And the lunches are great. They have a catering service that they use for the lunches. And I'm telling you, they use them every time that I have done the class. I love those guys. Those guys are top notch. The breakfast is usually like usually something simple, usually like coffee and a donut. And if you're on a restricted diet, I would encourage you to get you bring whatever it is that you would use for your restricted diet, which is what I'm on right now. So the first thing that we're going to go through is troubleshooting the refrigerator. Okay. Is it actually the compressor? If it is the compressor, how does the compressor work? I mean, these are basic understandings of what a technician needs to know. Okay. 5 reasons that my refrigerator won't cool. Okay. Number 1 is a power surge. We all get power surges. The newer refrigerators are more likely to have an issue with a power surge because of all the boards that are in them. Okay. The old style refrigerator where you had just either a small adaptive defrost control, or all you had was the defrost timer. And the defrost timer was a manual timer that you could actually advance. I still have one in my house that I use for odds and ends. It's a little over under refrigerator, so it's a great little refrigerator. I'm not going to get rid of it until the refrigerator dies, or either I live in Daytona Beach, Florida, or the refrigerator rusts out, which is probably what's going to happen first. Okay, so you have to be careful of a power surge. If it's a power surge, that's something you need to ask the customer. Have you had a power surge lately? If the answer is yes, ask them to unplug it, let it sit for 2 minutes, plug it back in, and see if the refrigerator comes on. If it doesn't, have them call you back. You don't need to be waiting 2 minutes. Okay. One of the other things that used to drive me crazy with brand new technicians is they just walked in and, it's not cooling. It's got to be the compressor. Well, it's not the compressor 99 times out of 100. Okay. Usually it's something else. A dirty condenser coils. Okay. Those are world's worst. I have gone out and you could have made a blanket out of the condenser coil. It was so thick. Okay. So always, the first thing I'll ever do if I have that complaint, I walk in and I pop off the toe plate. I check the coil. Okay. I make sure that it's not clogged. If it is clogged, I'm going to unclog it. The other thing, while I'm there, I guarantee you it's got dirt on it. Okay. So go ahead and take your coil brush and use the coil brush. And watch out, because you'll get it blowing right in your face usually, but that's a good sign. If you get the coil brush and you start getting dirt blowing out at you, that's a good thing, because that tells you right there that the condenser fan is working. Okay, so what will happen is if the condenser fan doesn't work, it's going to trip off, and it's going to trip off the overload in the compressor. And that could be your problem. Okay, I have gone out numerous times on a brand new technician, and that's what the problem was. It was so clogged up that it had literally taken out the condenser fan motor. So I had to replace the condenser fan motor. The unit will trip off on the high side because it's not circulating any air. And you can actually take the compressor out if it goes for too long. Okay. So I'm just going to make sure that the condenser coils are clean. Okay. I'm going to ensure the evaporator or the condenser fan motors are working. Okay. One of the things you need to remember is just by opening the door doesn't necessarily mean that you can hear the fan motor. Okay. A lot of times you have to open the door, depress the light switch, because most new refrigerators, if I open the refrigerator door or the freezer door, they shut the fan down because they don't want the fan sucking any air through it. Okay, so I'm gonna make sure that both of those run. Then I go down and the next thing I check is that there's no obstructions. Okay, and put in front of the vents. Pets love to lay down in front of a refrigerator. Doesn't matter if it's a dog or a cat. They love to lay down in the front of the refrigerator, especially in the wintertime. They get a little heat out of that, and they can their pet hair and dander gets it's sucked into the coil. Okay, so I'm going to make sure that I have no obstructions. Could be that the customer did not have the required gap all the way around the refrigerator, including on the bottom. So you need to check that. If that's your case, you need to let the customer know. Last thing that I'm going to find is it a seal system issue? Okay. Is it the compressor? Do I have a leak in the system? Do I have a restriction in the system? I need to know all that before I actually diagnose a compressor. Okay. I have been out on so many that it literally had a leak in the system, and then that in turn caused the filter dryer to clog. So it wasn't the compressor, but you still got to know that, and you got to test it. So number one is that's the last thing you're going to do, because that requires you to go out and get all your tools for a compressor. Okay. Those are the top 5 reasons. Okay. If the refrigerator is running but not cooling, what do I do? Okay. You're going to have to install an access valve on the low side. You want to add a small amount of refrigerant, check the gauges. If the gauges go into the same vacuum, it means you probably have a restriction. If the pressure rises, look for a leak in the system. Okay. Just something quick, simple for all technicians to be sure of that they're doing. Okay. Other thing, what happens if my evaporator coil is freezing? Doesn't matter if it's in the refrigerator or in the freezer. Okay. So the first thing I'm going to do, if I walk in and I go through and I find that my evaporator coils are totally frozen, I need to find out where my leak is. Okay. So I have an air leak somewhere. So I've got to find out where that is. Could be something as simple as you need to put a gasket around the door. It may have rips in the gasket itself. So you need to know that. If that's not it, you need to look around in the back of the refrigerator where all the lines come through. I need to make sure that I'm not getting air sucked through the lines. A lot of the times, on several of the manufacturers out there, I may have to actually totally go in and re-insulate the little terminal blocks that are on the back that come through the back wall. It could be that the water line coming through to the ice maker could be a problem. It could be that one of the other manufacturers out there has a problem with the gaskets that are sealed around their refrigerator, the refrigerator section, and that sucking in will actually, you can lose a fan motor because it sucks all the air in. It freezes right there at the fan motor. The fan motor stops, and then I got a problem. Okay, so I want to make sure that that it's going to work. Okay, my evaporator's coil is frozen. First thing I'm going to do is I'm going to put the unit into a defrost. I'm going to make sure that the heater comes on. I'm going to check the bimetal. I'm going to check any kind of timer issues that I might have. So I'm going to wait for it to come in and go into a defrost. Okay. If I'm looking in the ice in the drain pan, okay, it's frozen up. I'm going to have to clean that, which requires me to go get my steamer. I'm also going to find out if there's anything in that drain. A lot of the times you're going to find something as simple as a piece of corn or a pea or something like that has clogged the drain pan. It has now caused the drain pan to back up into the refrigerator or freezer section. Okay. I'm gonna figure out what that is. If something happens and it's not that, it could be as simple. The other thing that it could be is that I'm gonna need to move the defrost bimetal, so that whenever it goes into a defrost, that the drain it keeps it out a couple of minutes longer. So I'm going to have to check all of that to make sure that all of those problems are not my problem. But again, people will diagnose that as a compressor issue when in fact there is no problem with the compressor itself. Okay. What if my evaporator coil is frozen on one side? Okay. I'm going to look for a leak in the system. One of the other thing is if you have a really old GE refrigerator. It could be that if it's in a side-by-side, they had an ice balling problem. There has been another Whirlpool made one that had some problems with ice balling. So you need to be sure that you have checked your system to make sure that if you have GE or Whirlpool or any manufacturer, you go on and download any service bulletins on that product. Okay. Excuse me. So if my evaporator coil is frozen on one side or frozen at the top and not at the bottom, you're going to have to figure that portion of it out. But once again, that is not a compressor problem. Okay. So we're going to go on. This is a wiring schematic, okay, for a refrigerator. So on this one, it's a pretty simple little schematic. The only thing that you would be worried about, or if I'm not getting power, I may have a defrost issue, a timer issue. It could be a board issue if it's a brand new refrigerator. Could be a board issue. I'm going to have to go through and I'm going to have to physically check each one of those so that I can make sure that I'm diagnosing this properly. Okay. So if I get down to the compressor and I get no power coming into the relay, I know that I've got a problem other than a compressor. If I've got no power to the relay, that means my compressor is never going to come on. So I have to go back and figure out where that problem is. Okay. Always make sure that you do your due diligence, because if there's nothing worse than replacing a compressor and it not being the compressor. I can tell you a specific instance that one of the new technicians diagnosed a compressor issue. It was a guy that I had trained, and I thought that I had trained him better than I did, but it was actually a restriction in the system. I went in and I changed the compressor out, and it turned out that it was a restriction in the system. I changed the filter dryer out. Lo and behold, it all worked. And so this was many years ago. This is even before 1.432A. Okay. What tools will I need to diagnose a compressor failure? Okay. I'm going to have an assortment of hand tools. I'm going to need a cordless drill and assorted bits. The reason that I tell people about a cordless drill and assorted bits is because it used to be that there were about on a Whirlpool refrigerator, there used to be 13 screws that gave me access to the condenser. Make sure that you're doing that's the only reason that I have cordless drill in here. Normally, I would tell you just use a 1/4" nut driver or a 5/16 nut driver. Okay, but go ahead and use a cordless drill. You want to use a cordless drill to uninstall. Whenever you go to put it back in, please don't just load it up into your cordless drill and start driving that screw in. You'll strip them out, and then the next guy behind you has nothing but problems. Okay. One of the other things that I'm going to need, I'm going to either need an amp meter or I'm going to need a regular multimeter. Okay. Most multimeters are okay. You've got to get one that I can get amps done. I need an amp meter to be able to check the amps on the unit. Whenever I get it up and running, I need to know how much amperage the compressor is pulling. Okay. I'm going to need, right with this one, if it's a 134A system or something besides an R600, I'm going to need a torch. If it's an R600 system, I don't need a torch. I'm going to need the lock ring system. Okay. I'm going to need a set of gauges. I'm going to need a recovery system. In today's market, you are not required to, at this time, to recover R600. But at the same time, you cannot vent that into the atmosphere in the kitchen itself. There are too many other things that can happen that can ignite R134A. And if you start venting something into the air in the kitchen, you're probably going to end up somewhere, sometime, with damage to a customer's home. If I use a torch, it's not a matter of if it's going to happen, it's when is it going to happen. I have talked to technicians, and they're like, yeah, I always use a torch. I don't like using the lock ring system. You know what? The problem is it's not a matter of when it's going to happen, but sooner or later, you're going to have a flashback. One of the guys that I trained in Dallas about 6 weeks ago, on lock ring, his technician was out, and thank goodness it was at the shop. They had pulled the refrigerator out of the customer's home. They had brought it into the shop. The guy didn't pay any attention. He started to unsweat the joint, and he had a flash fire. Okay. What happened? Burned down the whole shop. Okay. It's not a matter of when. I mean, it's not a matter of if it's going to happen. It's a matter of when is it going to happen. Okay. Go out there and look on YouTube. All new technicians love going to YouTube. Greatest thing since sliced bread. Okay. Go out there and search R600 dangers, and it will show you. There is one out there that was a GE guy. He took it out to a field. He showed just how bad it was whenever that compressor was running and it had a spark. Once again, it's not a liquid that you have to worry about. It's a gas. Whenever it disperses in a gas in the air, it creates the flash point. Okay, so I'm going to need my gauges, my recovery system, and my process tube adapter kit if I'm going to do a 134A, and I'm going to need all of that. Okay, if I'm going to use the R600 issue, I'm going to use the lock ring system. It comes with their own set of gauges. If you use your gauges, don't use 134A gauges and then lock ring gauges. It'll destroy the gauges. You get problems all the way around. So you have to have a specially designed set of gauges. So I would tell you, go ahead and invest in. If I'm going to do it, I'm going to invest, because I want to have everything done and done quickly. Okay. We're going to get into why the lock ring system to me is much better. Okay. But let's just keep moving along. Okay. After determining that it is a compressor, what do I need? What are most of the problems that I'm going to see? Okay. I'm going to have like an overload failure. It could be a bad start winding, or it could be simply a locked rotor. Okay. So I've got to make sure what problem I've got before I go diagnosing and definitely find the compressor. Okay. So this is what an actual compressor looks like. Okay. Once again, like I said, YouTube is a great thing. This was on YouTube, and I borrowed it from them. I give them full credit on it. Okay. This is what a compressor actually looks like. I was probably been a technician for about 15, 16 years before we actually cut one open and looked at it. Okay, here's actually what a compressor looks like. So what does a compressor do? A compressor basically is the heart. Okay. It's like your heart. All the compressor does is moves freon throughout the system, just like your heart moves blood. Okay. What happens if I have a clogged artery? You know what? That's not my. That could be my heart, or it could be at my heart, or it could be the valve, the one of the veins or arteries going into it, and it will cause me problems, and I won't be able to function properly. Okay. So here's a little of what happens, okay, with the compressor. Okay. The suction line is moving the freon into the compressor. Okay. It goes through the bottom, up through a gap in the compressor that goes around the motor. Okay. I'm going to come down. It's going to then come down. It's going to come in contact with the suction valve. That suction valve is just like in a car. Okay. That suction valve opens just like in your heart. That suction valve opens as it comes through. Whenever the suction valve closes is whenever it starts to get pressure from the motor piston. It starts when the piston starts to push back, it closes the suction valve. Whenever it closes the suction valve, it opens the discharge valve, just like your heart. Okay. And then it goes through the oil there so that everything stays lubricated, and it comes out the discharge side. Okay. Here's the other reason that you have to be very careful about R600. Okay. R600 has a tendency that if I'm going to have, as the X600 moves through the system, it will leave part of the system. It will leave part of the refrigeration in the oil. So okay, so if I take it, I cut all that out. Let's say that I'm the technician, and I go in instead of that. I'm going to be bullheaded, and I'm going to use the torch for it. Okay, so I go through and I go to the suction line and I unsweat the suction line, and you know what? I'm fine. Then I go to the discharge side and I go to unsweat the discharge side, and that's where it's the lowest point and it has the most tendency to get some oil in it. Boom. I've just ignited it whenever I'm using my torch. Okay. R134A, you don't have to worry about that. It still happens with R134A in about the same quantities, but R134A is not an ignition point. Okay. Here's kind of what the compressor does. Once again, on the low pressure vapor side, it goes inside the refrigerator. It goes in, and it changes from a vapor to a gas. Whenever it does, it goes through an expansion valve. And then it goes to the high pressure side, which is the liquid side, and then it slowly changes back as it goes through the condensing coils, okay, back into a hot vapor. Okay, so anytime that I'm going to have to, I think I've got a compressor issue, I'm going to have to get to the compressor and I'm going to have to check it. Okay, I'm going to unplug it. First thing I'm going to do, I'm going to unplug the unit, because I don't want to be down there with 120 volts in this little small area. Somebody's going to get hurt. So I'm going to unplug the refrigerator. Then after I do that, I've got to remove this little box that contains all the components. It's mounted to every compressor. Okay. I've got to figure out how to get the box off. Whenever I started out, there was a clip that went from one side to the other. You had to depress the clip and pull it out. Okay. Today's compressors, they do anything from doing the same thing, or some of them have screws, or some of them have pins at the top and the bottom. But you got to know that, so you have to study that and learn what it is as it's going through. Okay, so whenever I get inside that, what are the components that are in there? I have an overload. Okay, in that you see the overload on the left. That's a new solid state overload. Okay, the overload on the right is a little round disc, and it actually flexes in and out. And then if I have a problem, it flexes out, and it won't allow the start relay to work. Okay. The overload in the solid state on the left side, which is the one that goes with the solid state relay. Okay. Once again, they're both at the same thing. If you look at the one on the right side, see the little wire that actually goes onto the compressor. Okay, there's a wire that goes into that overload that gives me some power. The other one is the other overload. You can tell that it has two outlets, but if you look at the very center of the white part there's a little piece that slides right onto the compressor. So I'm gonna have to check my overload, and I'm gonna have to check my start relay. Okay, how do I check the overload? Okay, if I have one that has a run capacitor attached to it, you're going to see that's you can see how it was done. Okay, this setup right here is for a new compressor that has solid state parts in it. Okay. So if you look at my overload, there's one wire that connects to the overload. Okay. The other wire, okay, connects to the terminal, and that's your 120 volts AC. Okay. Now, if I've got an old style and I have this relay right here to the right, I'm going to have to check it. Okay. The electromagnetic, the PTC relay, which is what this is called. Okay. I have to check that with an ohm meter. I'm going to look for the resistance that I find. Okay. If the relay PTC, I'm going to read somewhere between 2.8 and 5.2 ohms. If it's the other relay, you're going to read 3.8 to 5.6 ohms. You got to know your relays. I would tell you that I would save this. That way I know where it is, because I'm sure that there are a lot of old refrigerators out there. The one thing that I will tell you is refrigerators usually last longer than anything else in the home. My dad still has one from 1978 that he has in his home. So the electromechanical relay, okay. The relay in the position, I'm going to check the continuity between terminals 1 and 2 of the relay. If I get no ohms, I'm going to change the relay. With start relay in the vertical position, okay, the coil, that's where the coil is pointing upward. Okay, going to check between terminals 1 and 3. If I get no ohm reading from there, I'm going to change the relay. Okay, with the relay in the vertical position, which is with it pointing downwards, which is the opposite of the one that's in the picture to the right, I'm going to check to see if there's continuity between 1 and 2, and that's going to tell me if I have a good start relay. Here's the basic wiring schematics. Okay, so there's your thermal overload right there. Okay, then I have my compressor. Right here I have my start capacitor, and then I have my start relay. Okay. You notice that the thermal protector goes to the common, that the other side, the start relay, goes to the normally to the start components. Okay, and then it swaps to the run components whenever it starts. Okay, so how do I know if my compressor is bad? Okay, I'm going to check between common and start. I should get somewhere between 3 to 11 ohms. Okay, this is on a normal compressor. Okay, if I go between common and run, I should get 1.1 to 5 ohms. Okay, any compressor pin and ground, and I have infinite resistance, are open. Okay, I can check any of those. Okay, that tells me if I've got that and I have between ground and any component right there, that tells me that I have a direct short, and I'm going to have to change the compressor. If I have an inverter compressor, which there are a lot of manufacturers that are going to an inverter compressor, I should get somewhere between 6.2 and 11 ohms between any of the pins. Okay, so I'm going to make sure that I have all of this, and once I get all of this done, I'm ready to take out the compressor if I have those problems. Okay, there's two ways to do it. Like I said, a torch and a solder. I'm telling you, do not use a torch and a solder, in my opinion, to do R600. If you do, that's up to you. But I'm telling you, I would never use R600 with a torch and solder. Okay. So changing out the compressor, I'm going to need a set of pinch-off pliers. I'm going to need a set of gauges. I'm going to need shut-off valves. I'm going to need a vacuum pump. I'm going to need several assorted fittings. Doesn't matter if I'm talking about R600 or R134A. I've still got to have an assortment of fittings. Okay, I've got to have a plier type evacuation tool. Everybody was asking me what in the world is a plier type evacuation tool. So I went ahead and put a picture of it on the right side. That way you know that you've got it. Okay, I need sandpaper. I'm going to tell you that I always use the sandpaper roll so that I could tear me off a little piece and then tear that in half. I would, at that point, doesn't matter if it's 600 or 134A, I would take and wrap that one time and do an in and out like this to get the refrigerator. Excuse me. I would do all of that before I remove before I cut the fitting. Okay. Don't ever do it, but after. If you do it after, the problem that you've got is you're going to you run the risk of getting that into the system itself. Okay. The sandpaper, you can actually get the little chips from the sand on the end to it that'll clog up the filter. Same thing with you could get parts of the whenever you cut it. If you're not careful, you can get parts of the copper or the copper steel or the aluminum that's in there into it. So be careful whenever you're doing that. Okay, with a 134A system, I'm going to need some flux. I'm going to need silver solder. I can't use regular old solder because it's not strong enough. So I need silver solder. I always tell you need a mirror. Doesn't matter if I'm doing 134A or lock ring. I need a mirror. And then I need some type of leak detection. Okay. So in a 134A, whenever I'm going to do this, these are examples of torch tips that I can use. Okay. My personal favorite was the one on the top left. Okay. That gave me that I could get around and put that heat right directly on it. Okay. You use the one on the right? Absolutely, you can. If I use the one on the bottom, it's more of a it's almost a map gas type because it makes it very loud whenever I'm doing it. Okay, so but like I said, the top one on the left is the one that I always liked. Okay, so how do I adjust the flame on an oxygen acetylene torch? Okay, and that's the only one that you can really adjust the flame is if I have an oxygen acetylene torch. I mean, I can adjust just an acetylene torch. I can turn it up and down depending on how much flame I want, but I don't really have any adjustment to it. Okay. Now there are three types of flames. Okay. There's a carbonizing flame that's at the top there. There's a neutral flame that's in the center, and then an oxidizing flame. Okay. If I get anything other than one that's very close to the one that's the neutral flame, I'm going to have all kinds of problems. If I have an oxidizing flame, that means I'm going to get soot everywhere. If I get a carbonizing flame, it just never gets hot enough, and it's going to cause problems whenever I try to solder. Okay, here's the problem that you're going to find out if you use the oxidizing frame. This is actually a technician that was trying to use it, make a replacement. And I got a picture of him doing this, and we had a discussion on how I could help him learn more about how to do a flame. Okay, if you look right here, so different tips for different jobs. You can see right here. Okay. So here's what I have to take in with me if I'm doing 134A. You don't necessarily have to take your tank in, but you have to have something to recover it in. Okay. If I've got a bag, which you can still buy, I can recover it, but I have to go out to my truck and I have to suck it into my tank. Okay. But these are still everything that I'm going to need. That's a whole lot to carry. The one thing that's not even that is not showing in this picture is I have to have my different sizes for my compressor. So once again, like I said, even with the pardon me, I apologize. Even with R600, I still have to go in and use my right tips so that I could get a good seal. Okay. Does anybody have any questions? We're going to take just a second here and allow me to get this one taken care of and move over to the okay. Guy, you're asking, how do I download the service manual and where? Well, here's the problem with that. Okay. With a manufacturer, it depends on the manufacturer that you're using. If it is a Whirlpool or a Whirlpool type product, you can go to Service Matters. You have to have a subscription for any manufacturer. Nobody gives them away for free. If something happens, okay, yeah. Where should the flame be on that, Jay? I'm going to go. I'll get back to that in just 1 second. Let me finish with guys here. So you can go to a search engine and you can type in service manual for and then type in your whatever it is that you're looking for a service manual for. That's one way to do it. If you don't have, like, Whirlpool has their Service Matters, GE has theirs, Haier has one, any of the other, Samsung has their own, but they all want you to be whatever it is, certified by them. If you have, they want you to do warranty work for them. So if you don't do warranty work, then you are going to have to go to the internet and go search for it. Now, be careful that you're searching for a service manual and not a consumer manual. Right. You're exactly right, Peter. You can get them from them, but you're right. It takes so long to get them, and then you're killing trees is what we call it. Okay. You have to, and you're exactly right, Peter. You have to make sure that you get the one that has the right wiring diagram with it. Okay, so Jay, let's go back. I'm going to add this one to the stage. Okay, so okay. So the flame that I'm looking for, okay, is very close to this neutral flame. Okay. I'm going to, and where am I going to put my torch on that is the hottest part is of the cone, okay, is the blue. Okay. So I want to make sure, and you can definitely tell, like if you look at this cauterized, see the difference in the cauterizing flame. Okay. That's what I don't want. My neutral flame right there. I can put it in there and it'll give me almost, I'm going to add just a little bit more oxygen to this, and that'll bring me to the tip that I want. Okay. I hope that answered your question. Okay. So we're going to go on. We're going to move on. We're at about 46 minutes. So we're going to talk about hydrocarbon refrigerants. Okay. This is the instructions. Okay. Safety. This is actually for a live class. One of the things I want to talk about is it's almost come full circle. Okay. Back in the 1900s, 1930s, they developed refrigerant because they figured out how to do it, just like how they figured out how to do a microwave. In the 1930s, they developed CFCs because they were non-flammable. And one thing that you'd never want to do is get into a system that used some of them used propane. Some of them used ammonia. You just need to watch and be sure which ones you're dealing with. Okay, the 70s they discovered ozone depletion. Okay, in the 80s they came up with an HFC and an HC to replace the CFC refrigerants. Okay. In 2000, they started an HC ice cream cabinet. Once they launched the HC ice cream cabinets, they found out that worked really well. So they started transitioning over. So in 2005, they had over 50,000 HC cabinets in use in Europe. So in 2020, they had over 550 million HC appliances worldwide in use. So guess what? That's where we are today. It started to move. You now cannot use your HFCs or your CFCs. You have to recover all of them and go and move them along. Okay. So here's what we're talking about. R12 is a CFC. Its ozone depletion rate is 1.0. Okay. R134A is an HFC. So R12 is where I started. Okay. Then R134A is an HFC. Okay, that has no ozone depletion. Okay, and then has 1,430 GWPs. R600A is a HC. It has zero ozone depletion, and it only has 3 GWPs. Okay, so here's the step down chart right here. As you can tell, you look at the bottom, you can see 2016, 2018. We're stepped it down to 2024. You show that it's 60. The EPA has ruled if the EPA rule went into effect at 2024. Now at 2028, we have it. I'm sorry. At the EPA rule is that it could have a something at or below 1,200 GWP. Okay, whenever it's 2028, 2029. I'm sorry. I've got to have it's going to have to be 30, and it's got to be around 600 GPA. It can be right at 600, or it's got to be lower. And as it steps down, you see where we're headed exactly. Okay. All right. So there's R130, R452. These are used mainly in R452 is usually used in commercial ice makers and outside for your home with your air conditioning system. R600A, okay, it's an A3. Like I said, the R452B is an A2H. Okay, it requires recovery. R600 doesn't require recovery. Neither does R290. Okay, so I have to have 3 things for a flame to occur. I have to have fuel, I have to have air, and I have to have an ignition point. Okay, so with those there, if I complete that triangle, I've got an ignition point. If I don't, okay, then it's not gonna flame. Okay, so a sudden release of refrigerant can result in a flash fire, a sustained fire, or an explosion. If you go out there, Reggie has several instances on his Facebook page of people that have gotten burned, have had an ignition point with a flash fire in a customer's home. A sustained fire would be one where you had to call the fire department. Okay. The lower flammability limit is the LFL. Okay. So it requires oxygen and refrigerant. Okay. Upper flammability is the UFL. Okay. That's the 290 and the R600. 9.5 for 290, 8.5 for R600. So you can tell that for an R290, the LFL, you're at 2.1%, and it's 9.5% at the upper flammability level. Okay. So who causes you to recover refrigerant, or says that it's okay that you don't recover refrigerant? Okay, this is the EPA is number 1. ISO, which is your ISO 9000, 960, 9600. All of those are your ISO, International Organization for Standardization. National Fire Protection Agency. Okay. If you're in Canada, the Canadian standards. Okay. International Electromechanical Commission. Underwriter laboratories. This is the ones that you're familiar with. With us, I'm going to skip Canadian, European. Okay. American Society of Heating, Refrigeration, and Air Conditionings. Those are the initials for them. If you notice UL is there, that's one of the things where you get hurt the most if you violate that policy. Okay. So what does a label on a compressor tell you? Okay. It'll be the charge size, the refrigerant type designed by the EPA and the SNAP regulations. Every time that you go and you replace an R600 compressor, you have got to have this sticker present so that somebody can see this, so that they know exactly what type of compressor it is before you install it. If it's not on yours, you're gonna have to get one and put it on it, because you cannot have it without this label that's on the top. Okay. You can't do any retrofitting here. All labels must match and meet UL specifications. And UL has said that it has got to have this explosive flammable refrigerant warning. Okay. Here's your safety resources. AHAM, American Association of Home Appliance Manufacturers. This is the one that most everybody knows. Most of these are different other areas. One of the things, okay, if I'm going to use and go to a combustible refrigerant, I have got to have these two items with me inside at all times. Okay. I have to have a combustible leak detector, and I have to have that on so that I know as a technician if I'm reaching that point where it might ignite. Okay. I need to have a dry powder fire extinguisher. Okay. You don't have to have that inside the house. I would tell you to take it in, but that's me. But if I'm going to transport R600, I've got to have it. Okay, that's no ifs, ands, or buts. If the DOT stops us and we don't have the dry powder fire extinguisher, I'm getting a ticket. Maybe that I'm pulled off the road until I get one. Okay, you're going to need a tubing cutter. Don't use a torch. A well ventilated area. And I'm going to eliminate any ignition sources that I have. Okay. What are ignition sources? Okay. If I have let's say I have a dryer that is I'll tell you an example. My parents have a laundry room right off their kitchen. And they have an electric, a gas dryer, or it could be electric, doesn't matter. Because as the gas dryer heats and ignites the flame, okay, I have an ignition source. If I have just a regular old electric dryer, same thing. It gets so hot that it would ignite. Okay, another ignition source. Hot water heater would be an ignition source. You using a non-brushless pump can ignite R600. Okay, so if I'm not using a brushless vacuum pump, I can ignite it just from the sparks that are going around in your vacuum pump. Okay. You've got to have a well ventilated area. Okay. Obvious ignition sources, we're going to talk about those. Burning materials, cigarettes, candles, toasters, ranges, dryers, electric or gas, torches or spark igniters. Those are all places. Over-lit ignition systems, okay. A vacuum pump, recovery equipment, timers, switches, contactors, anything, even static electricity can ignite this, okay. We all know whenever it gets a little bit cooler, which I hope happens here really quick, just by walking across a floor, I can charge my own body and have a static electricity, and that can be enough to cause an ignition. Okay. Leak and detection line repair. I'm going to use my tubing cutter to remove all the components. I'm going to use soap bubble or a certified leak detector. Okay, if I'm going to check and I'm going to do things. I don't have to use dinitrogen, but it's good to have it if I have any condition that I think I have a problem that I may need dry nitrogen to blow through the line. I have to constantly monitor for flammable the environment. Okay, this is for an R600. Okay, so I'm going to leak and line repair. I'm going to purge the gases to an exterior environment. I will tell you that one of the things that Reggie had on his Facebook was somebody was outside smoking, and the guy ventilated the line to the outside around where the guy was smoking, and it ignited. Okay. Be very careful about where you choose to do it. I have a bag that I use. Whirlpool used to have one of these. I loved them because it didn't require me to carry in all my junk for recovery, and I could do it all in the truck. But I didn't have to carry it in the house. And then I just sweep charge it. Today, you can't really sweep charge it. Okay. So red paint marks, I've got to put those on there to the access fittings. Okay. Always remove any piercing valve. That's the reason I use that clamp pliers, because I can pinch those off, and then I can remove my piercing valve. Okay. Lock ring fluoresces a bluish green under UV light, which is looking at the bottom. Okay. Common refrigerant dyes fluorescent as a bright yellow. Environmental conditions, lights off. That goes without saying. If I'm going to try to use a UV light to check, this is what I'm going to see. Okay. Okay. So, like I said, lock prep fluoresces a bluish green, and that you see it right there. Okay. Refrigerant dyes do a bright yellow. You see it there. Okay. So recharging or replacing the refrigerant. This is on your R600 unit. You can tell that they have their gauges. They have their brushless. Let's just go through. Match the refrigerant type and charge to the label plate. Don't just guess. Repair all refrigerant electrical faucets. Secure power and discharge all capacitors before you service it. Once again, risk of ignition. System remains grounded. You got to make sure that it's grounded. Lines not exposed to corrosive materials. And renew seals and sealing materials. Okay, so as you can tell, this is the system that that you get from Lockring. It comes in a nice little case. you notice right there in the top of the case, their refrigerant, their lines, they're not even using those. They're draining them right into a bag. Okay. This is your piercing tool that I was talking about. Okay. I'm going to maintain my ventilation. A fan would be good, a little portable fan. I mean, I've got one that I use whenever I'm down in the shop. I use a portable fan so that I can just keep the air moving. But for R600, you want a ventilation. Okay. Once again, it has to be brushless. If it's not brushless, it's an ignition point. So you have to be careful about your fan. You have to be properly grounded. You have to verify the venting. Okay. Temporary vessel for release. That's the bag. And then combustible compatible hoses and sufficient length. Okay. The one thing you want to make sure of, like I said, I don't want to use the exact same that I use for 134A or 452. I need to have a spare set of gauges with hoses on them, and they have to be the right length. Okay. After servicing, I have to make sure that I have all my safety levels in place and intact. Red markings. I'm going to put red markings on the process tube to show that I have changed the compressor. Install ventilation features are intact. Compressor oils need to maintain a residual refrigerant. 0 PSI does not always mean 0 refrigerant. One of the important things to remember. This is the picture of the case that you would get if you ordered it from Lockring. Okay. They have changed this case. They came to understand that this case cost so much money that they were spending about a third of what the money that they charged you was because of this case. So they now have it. It's cheaper. It's actually comes in a little pouch with everything in it. It's still a whole lot. It's still nice, and it takes care of everything. So what comes in my kit? I get a compact digital scale. I get a LP and an HP valve manifold gauges, the high pressure, low pressure, R600 extraction valve, okay, liquid extraction disc, ball valves and tees, valve core depressors, and hoses. This is what's in this case itself. And it comes in an instruction manual. Okay. I'm going to perform a safety check, monitor with a leak detector, run the refrigerant for 5 minutes to warm the oil, then unplug it from the outlet. This is so that you get some of the oil out of it. I'm going to install a suction gauge manifold, install a discharge hose to the piercing pliers, route weighted end outside, and pierce the dryer. Okay, I'm going to pinch off the capillary tube, confirm gas is being discharged. I'm going to start to monitor the unit, monitor the pressure, and archive minimum of the stable atmosphere, unplug the unit, remove the pliers, and perform service. What it means by archiving the minimal, if you look, there's a dial gauge on your gauges here. See, there's red. I want it to get, that's the lowest point that it sucked it down to. I want to make sure that I do that before I discharge everything. Okay. So connection to both sides of the system. I'm gonna pass a discharge, and I have a assisted discharge, and then I'm going to use a passive discharge and repeat. That will help move any trapped refrigerant in the lines. This is the way that you want to route everything. Okay, this is a very important slide when it comes to Lockring. And I will tell you, the first time that you do this, you're going to go, do I put it here to here? Oh, man, I'm lost. In the kit, this is included in the kit, so it shows you exactly how it's routed. Okay? You need this bad. This is the proper way that it works. If you don't, you're going to end up with problems. If you charge if you charge the gas on the high side, you'll never get it out. If you charge liquid on the low side, you're going to blow the gauges up. One thing I can tell you, if you send Vulcan a low side gauge, and you happen to have used it for liquid charging, they will send it back to you and say thank you, but no thank you. Here's the part number for you to buy a new low side because it blows the gauge. Okay. So, like I said, I'm going to warm the vacuum pump up. The extraction adapter valve remains closed. Open all the remaining valves. I'm going to record the lowest vacuum leading, which is what I was doing. Perform a leak check by isolating the vacuum pump anti-siphon device. Okay. Then I'm going to open the valve depressors, conduct an evacuation until the minimum of 29.9 Hg vacuum is maintained. You can see it right there. Monitor for pressure rise. If none, then if I don't get a pressure rise in a couple of minutes, then I'm ready to charge. Okay. If the system is over 40 grams, you got to charge it liquid. If it's under 40 grams, you have got to charge it on the you can't use you can't charge it to the liquid side. Okay. Close the manifold gauge if it's connected. If it's under, close the ball valve to the extractor. The ball valve to the vacuum pump remains closed. Okay. I'm going to place the bottle on the scale. I'm going to tare it to 0. I'm going to open the extraction valve on the bottle. Do not move the bottle from that point. If it falls off, you have to go back and you have to re-tare it to 0. Okay. Always make sure that that's done, because if you don't, you're not getting the proper charge on it. Okay. Open the ball valve. Fill the ball valve. Fill half to the charge. Okay. Energize the compressor. Cycle the ball valve until the charge is reached. So what I'm going to do is I'm going to open that ball valve, and you're going to get somewhere around half of the charge in it. Then you're going to have to energize the compressor. You're going to cycle the ball valve until, in other words, open and close the valve so that you reach the charge. Close the extraction valve. Once you do that, open the ball valve. Open the ball valve once 0 bar PSI is reached. Then I'm going to close the liquid side manifold valve. Okay. Not recommended for charges under 40 grams, and we've already been through that about 4 or 5 times. Okay, I'm going to close the HP manifold valve if you've connected it. I'm going to close the ball valve to the extraction adapter. The ball valve to the vacuum pump remains closed. The liquid line extraction disc. Then I'm going to place the bottle on the scale. I'm going to tare it to 0. Once again, if something happens in the ball valve and the unit gets knocked over, in this position, it's a whole lot harder to knock it over. In the other position where you're charging it on the on the vapor side instead of the liquid side, you run the risk of knocking it over. I've actually knocked it over. Okay, so I'm going to open. This is liquid line charging. Don't forget. I'm going to open the extraction valve, pre-charge the ball valve. I'm going to open the ball valve, fill up about half the charge. Then I'm going to close the valve. I'm going to cycle the ball valve rapidly until it's fully charged. I'm going to close the extraction valve, and I'm going to open that ball valve. I'm going to wait 1 minute. After I did that, I'm going to start the compressor, and then I'm going to reach 0 bar PSI. Then I'm going to close it to the liquid side manifold valve. Okay. Verify the compressor is running. Crack the valve core depressor at the dryer. Open the manifold valve. Slowly open the liquid pressure manifold valve until both gauges reach the same pressures. Close and remove the valve core depressors. Okay. Once I close the valve core and the depressor is removed, okay, I'm going to apply lock prep to my threads and install the caps. You can always crimp that off and put it at the Schrader valve, just before the Schrader valve. Then I'm going to apply red paint to the servicing port tube. That way the technician that comes after you knows exactly what it is. Okay? Okay, we ran over 16 minutes. I have a question for you all. What did you... I still, the problem is you have an open flame, Peter. Okay, with an open flame, R600 does not like an open flame. It will explode. It will cause a flash fire. It'll explode. It depends on where it gets. So I am not a fan at all of anything with R600A. I want to use nothing that is going to cause a spark or an ignition source. Does anybody have any questions? Like I said, we ran over today. I apologize. I hope that everybody got understanding of how to do it. If you have any other questions, my name is and email are scrolling across the bottom of the screen. If Reggie's is doing the same thing. I've got to get all of the regional managers like Reggie and maybe put them in and have this so that it sends to everybody, and that way everybody knows their regionals, and they can call their regionals instead of everybody calling Reggie. My email is down there. My phone number is also down there. If you are going to call me, do me a favor, send me a text message first, so that I can make it so that you get your I answer your call. I have my phone set up for a robocall. I'm willing to be the service company tester for the letter. David, you're exactly right. You know what? But I'll be honest with you, David. The first thing that I want to test, I don't really want to test the regular lock ring unit. I want to test the mini lock ring. It costs, just the tool itself costs as much as the whole set that you get. It actually costs more than the whole set that you get. It's called a mini press. Go look at that. But let me tell you, you talk about being able to do something really fast. You're supposed to be, and I don't doubt this at all. You're supposed to be able to change a compressor from beginning to end in less than 30 minutes. Yes, but the benefits are there. If I'm doing like I used to do, whenever I worked for Circuit City, I know they're all gone and they died. But whenever I used to work for Circuit City, that's what I did. I did a whole bunch of compressor changes. Oh my gosh, it would have made it. You're exactly right, David. But that would have made it so much simpler. I mean, because you got to remember, I don't have to take my torches in. I can use you can use lock ring for 134A. I mean, it's not flammable, but how much easier would it have been once I ran the gas out. I can do lockering and it's not flammable. I just whip, throw that back in, put my joints back together, seal it off, charge it, and walk away. I mean, plus I don't have the thing. And David, I'm just going to tell you, the one thing that I always hated was how much junk that I had to carry in. You know, I had to carry in my torch, and I had an oxygen acetylene. So I had to carry my oxygen acetylene torch and my box that I carried, because I had a box that had everything. I had my pliers, I had my fittings, I had my sandpaper, I cut the pieces so that they fit in my box for my silver solder. I always, as a technician, I always took and used flux. So that was one trip in. Then I had to go back out. I had to get whenever I worked for Circuit, I had to go. They wanted me to carry my tank and my recovery equipment, all of it, my tank and my recovery system. So I had to carry. That was one trip in. Then I had to get my gauges, my vacuum pump. That was another trip in. I mean, that was 3 trips, and that's 3 trips in, 3 trips out. All right, guys, we're way over. Thanks, David. I appreciate it. I don't know who's left. Hang on just a second. Let me see if I can tell who's left. And it doesn't tell me. But thank you, everybody. But you're exactly right, David. These days, my back, my everything else, it don't work like it used to. See you next time, everybody. Thanks again.